All right. Hey, everyone. Welcome to Data Science for Everyone, week 7. Yeah, I'm pre-recording this lecture because basically everyone's on a different time zone. So this will make it a lot easier for people to just watch it whenever. And then, well, I'll get into it, but my office hours will be by appointment. I have a big email backlog right now. So if you emailed me, sorry if I haven't replied yet, but right after this, I'm gonna go through and reply to my emails. So yeah, it's my cat. I don't know if you can hear that, but cool. So let's get started. Basically go to, let me do screen sharing. There we go. All right, so we go to DSUA-111.rcmiu.org. Same place we've been going the whole time. Click spawn. Still my cat. His name's Hugo. Now you know. He's a new TA, cat TA. So wait for all that stuff to happen, and now you should be able to go to class materials. Nope. Your materials. That's it. Your materials. TA sections. Week 7. Jeff. And then there's just one notebook in there called week 7. Oh, I should say right now that there's no lab this week because we basically just made lab 5 and everyone's gonna get credit for it. So I should have said at the beginning that if you're tuning in to get credit for a lab, you don't need to watch this. You can turn it off now because yeah, there's no lab. We're just gonna like go through material that would be on the lab if we were gonna make one. But yeah, if you decide to stay, well, welcome, and yeah, welcome back. Very unique circumstances. I'm in self-quarantine, I guess, with a friend in Tennessee. I'm not from Tennessee, just friend had an open house in Tennessee for quarantining. And yeah, all the grades are now on Gradescope. So on Gradescope, we've like put in formatting penalties, late penalties and stuff. We had a couple of cases where like it said late, but you actually turned it in on time. And then like you resubmit it or something. So just email us if like you got marked late, but you didn't actually hand it in late. Because basically we're just going by the time that it says in Gradescope, but you know, we could check like the submission time on Jupyter Hub if you submitted one but forgot to submit the other or something like that. Yeah. Midterm feedback, grades and feedback you can get on classes, right? So I don't know how y'all get there, but I go to like newclasses.nyu.edu. Yeah, future feedback for auto graders. We are now distributing to everyone through NYU Drive. And so that was like a nightmare to figure out, but I wrote a little script that basically just like we upload the HTML files that contain your feedback. And it has like, you know, the assignment name, your net ID, and then the timestamp of the grading. And I just wrote a script that like loops through each one of them. We'll learn about loops today, but it loops through each one of them. It looks at what the net ID is and it shares it with just you. So you should have a bunch of, like by now, you should have a bunch of shared HTML files on NYU Drive, which is, by the way, just I think it's, yeah, it's just drive.nyu.edu. And yeah, you can find your feedback there, or you should have gotten emails that your feedback was shared with you. And a key thing to note there is that you don't, you can't, like, Google Drive doesn't allow you to preview HTML files correctly. Like if you click preview, it just shows you like the HTML code, which is not what you want. What you want to do is take the HTML file we shared with you that has your feedback in it and download it, right? So just click like the download button in NYU Drive, and then open the downloaded file in your browser, and it'll show up correctly. It should have like your name and net ID at the top, and it'll have your total score, and then it'll have a breakdown of each question and the, like, you know, either 1 out of 1 on that question if you got it correct, or 0 out of 1 if it's incorrect. And then you can scroll down and it'll have all of your cells along with the autograder code. And then if there's an error, it'll show up so you can see exactly like where in the auto grading code your code failed or didn't fail. And yeah, office hours by appointment, because yeah, I feel like most people are, a lot of people are not on East Coast time anymore. So just email me, I'll do my best. Hold on, there's a gigantic bug. I think that's a wasp. All right, sorry y'all, there was a wasp in that attic that I was in. So yeah, I'm not gonna record in there. So now I'm just in like the main room. Like I said, self-quarantining in Tennessee, not where I'm from, never been here before. And yeah, mostly just playing new Animal Crossing. So if you've got that and you're trying to catch some bugs, holler at me and I've got my friend code. But yeah, all right. Wow. There was a wasp. Yeah. So back to the screen sharing. All right. Questions, email me, office hours by appointment, email me, etc. Yeah, so for the project, I'm going to be sending out a Google form that me and the other TAs, Will and Angela, made, that basically just like has some like leading questions that will help you, you know, figure out the steps of your project. So it'll just ask like, what is a row? Like, what's your data set? What questions are you asking it? And then specifically, like, what does a row in your data set represent? What are the variables that you think are, you know, that you want to explore? It doesn't have to, none of this has to be final. The whole form is optional, right? And then it'll ask things like, well, how big is the sample? And like, how did they take the sample? Like, did they randomly call people? Like, is it a poll? Or is it like data for each row is a country? Or is it data where each row is a country and year? So like the happiness data set that we looked at, you know, it has like Afghanistan 2008, Afghanistan 2009. Yeah, we just have a Google form that asks you a bunch of questions to try and figure out the details of your project. And yeah, if you know what you're doing, don't worry about it. But if not, yeah, fill it out, and then like it'll help me, because then I can email you and be like, hey, that data set isn't gonna work, or hey, that data set looks great, go forward with it. So yeah, today's agenda, like I said, there's no lab, but we're gonna review if statements for like 10 seconds, and then go on to for loops, and then talk about the law of large numbers. There was like a question about law of large numbers in Andrea's lecture yesterday, so talk about that for a little bit. All right, so if statements, yeah. It's kind of like the most basic way that you can control what happens in your program. You know, like without if statements, the program is literally just like starts from the top of, you know, the cell, and it just runs each line of code continuously, right? If statements are the first time that you've seen where you can kind of control that, and it's running from the top, but it hits an if statement, and then any code that's indented, like this code here, it only runs, right, if the condition on the if statement is true. So it's just saying like, it's the first time that you're able to control like, oh, actually don't always run this line of code, only run it in this case, and you get to specify the cases when it should run code. So in this case, defines variable A and a variable B, and then, it'll run this line if A is bigger than B, and or this line if otherwise. And in this case, B is 20 and A is 10, so A is not bigger than B. So it checks this, says, nope, not that one, and it goes down to the else statement and says, okay, print B is bigger. Hence this output. Yeah, Python is whitespace delimited, which means that the things basically inside the if statement need to be tabbed over, right? So we have this whitespace here. And Python's like very weird in that it'll actually, as far as I know, it'll accept any amount of whitespace to show like, oh, this line of code is inside the if statement, whereas like this other line of code isn't, as long as you're consistent. So if you have one with like 4 spaces and one with 3 spaces, it's gonna give an error. But yeah, typically you do like 4 spaces to show like, oh, this line of code, don't always run it. Only run it as part of this if statement or this else statement. So in this case, right, you're gonna get an error because the print statement not indented. So Python is kind of just running and it hits this and it says, okay, well, there's no indented code here, right? It's just a blank line. And then it goes here and it's just gonna always print this, right? But, well, it would always print it, except it's gonna get an error before that because it's gonna say there's no indented code, like, I don't know what to do if this is true, right? You haven't put any code, so that's the indentation error. Right. So this is like the correct, well, define A. Yeah, so this is like the correct version, and it just says, okay, if A is greater than B, well, it's not because, again, A is 10 and B is 20, so it doesn't print this indented line, but it does run this non-indented line, right? Any line that's indented, none, it's just like leftmost, it's just a line left. Python's just always gonna run that from top to bottom, so. And then, yeah, last thing is just that you don't only have if and else, you also have elif, which is short for else if, which lets you give like other cases, like sometimes it's like a binary, like, oh, either this or this, but sometimes you have a bunch of cases, right? Like in this case, if A is greater than B, you print that. If B is less than C, you print that, but there's a bunch of other things that could happen, right? You could have like A is less than or equal to B, so then that's false, but then also B is greater than C, so that's false. And so, you can have else ifs to just have it check a bunch of different cases. And then even with all the else ifs, like you can put as many as you want, and you can still have an else that says, all right, if you've gone through the if and all the elifs and nothing was true yet, then just print this. So in this case, right, A is not greater than B because A is 10 and B is 20. B is not less than C because B is 20 and C is 5. So it hits this and it's false. So it goes to the else if, it checks this, also false. So it goes to the else and prints. I'm not sure what these relationships are. Cool. All right. For loops. For loops are the next like fancier way than if statements to control the flow of your program, right? Like if is kind of like putting a fork in the road, right? Like the program goes and it hits the fork and what you put in the if statements tells it what code to run. Whereas for loops are, I don't know, to continue that metaphor, it's like putting a loop in the road where basically you can have a block of code, but say you want it to run over and over and over again. That's what loops are for, right? And for loops are the most, in Python, the most straightforward type of loop. So it basically just says like, I mean, the main way you're going to use it is, yeah, you just have you're trying to go through a collection of things, and the for loop says, okay, I want you to go through like this array or this list or something, right? And each time you run the block of code I give you, like supply me, give me one thing from the collection, right? So yeah, in the example here, a deck of cards, going through each card in the deck is like looping through the deck, you know? So the for loop says, okay, here's a card, and then you do something with it. And then you throw the card away, and then it gives you the next card, does something with it. Throw the card away, here's the next card, right? So you give it a block of code and it runs it some number of times that you specify. In the case of a deck of cards, since there's 52 cards, you could write a for loop to do, you know, whatever code you wrote 52 times, one time for each card, right? So yeah, you might want to go through every row in a data set, add up all the numbers in a collection of numbers, run a simulation doing the same thing thousands of times, et cetera, et cetera. So yeah, an example is like here, you have this list of numbers, right? We've seen lists before from earlier in the course, but you know, before you kind of worked with the list as like a full unit, like you worked with it as a variable, but for loops let you kind of go into it and kind of like hit each thing inside the collection and run some code based on it, right? So in this case, you're running a for loop, and the syntax is like this, you write for, and then you say, this variable right here, this is the variable that you're going to be able to work with inside each loop iteration, right? So this is the variable that will get thrown out and replaced each loop iteration. Whereas this, then you put in, and then this is the thing that you're looping over, right? So my numbers is this full list here, right? So what this is saying, right? This is like crucial to understanding for loops. The kind of English sentence for what this is saying is it's saying, okay, go through my numbers, like dear Python, please go through my numbers, and for like start at the beginning and say this number is 1, right? And then run this code with this number equals 1, and then throw that out. And then say, okay, take the next thing and set this number equal to the next thing, right? So now this number will equal 2, and it'll run the code. And then you throw it out, and then it sets this number equals to 3, and then you run the code and you throw it out, right? So each iteration, this variable right here is what you have to work with. This is like the current element in the list that you're looking at, whereas this is the full list that you want it to pull elements out of, right? So in this case, all that the code is doing is it's saying whatever the current, you know, this number is, just print it out. And what we see is that, yeah, the first time that the loop runs, it prints 1 because this number has been set to 1. And then it hits the end of the code loop and it like says, okay, there's only one line. And it hits the end of it and it goes back up and it says, all right, now next thing is 2. So I'm going to set this number equals to 2. And then runs your code. Your code just says print it, all right? So it prints 2. It says, all right, I've hit the end, throw out the 2, go back to the start, set this number equal to 3, right? So again, the variable right here on the left is basically the current element that you're looking at, whereas this is the thing you want it to pull elements from. Cool. So that's what's going on here. It prints 1, 2, 3, 4, 5, 6. This just kind of says what I said, but yeah, this number changes value for each step in the loop. First it will be 1, then 2, so on until it gets to 6, right? So at a certain point, Python will say, all right, I have gone through everything in my numbers. I've set this number equal to all of them. This number was 1, this number was 2, this number 3, 4, 5, and 6, and then it ends, right? And in this case, it's the end of the cell, so Python's done. It says, all right, finished. Cool, so the number of times that this will run is just however many things are in my numbers. Cool. So in this case, if you think about it, like it's kind of like scientifically we'd call this memoryless process because it just prints the number and then it throws it away, right? Like after you're done, there's no kind of like lasting impact of it. But in this case, say we want to go through and we want to actually like, combine the numbers in some way. So this is your first example that you'll see of that. We have my numbers is a list, and then also we're going to make a variable called sum of my numbers, right? We're going to go through in a loop, but instead of just printing it out and throwing it away, we're actually going to like start accumulating the amounts, right? We're going to add it to sum of my numbers. So if you look at it, this is actually the same for loop code, like for loop starting code as in before. It's for this number and my numbers, right? For this number and my numbers. But this time, instead of printing it, we say, okay, take the sum of my numbers. And remember, the equal sign means assign it. It's like an arrow kind of. So sum of my numbers equals the old sum of my numbers, right? Plus this number, the current number. So since we started sum of my numbers as 0, what will happen is that the first iteration, right? First iteration of this loop, it sets this number equal to 1, right? Because it's the first element. So it says sum of my numbers, which was 0, plus this number, which is now 1. Put that into sum of my numbers, right? So each time it goes through, remember when you do an assignment with the single equal sign, it runs the code here on the right-hand side, puts it in the left-hand side variable. So it'll take whatever the sum of my numbers was before, it'll add this number, and it will put that new sum back into sum of my numbers, right? So first it's 0, and then in the first iteration, 1 gets added to it because 1 is the first element. In the second iteration, 2 gets added to it because 2 is the second element. And then 3 gets added, 4 gets added, 5 gets added, and 6 gets added, right? So by the end of this, it has run this line of code 6 times, right? Once for each element in my numbers. And it has done addition 6 times. So that at the end, even though remember, it throws out this number at the end of every loop iteration, we're kind of keeping track, right? Like we're not throwing out all the information because we're keeping it in the sum, right? We're summing it. So in this case, we can take sum of my numbers and print it. Well, I need to run this first. We get 21, right? So it hit 1, it added that. So it started with 0, then it added 1, then it added 2, then it added 3, 4, 5, 6. Cool, and that's how you get 21. Great. So yeah, now this is just like adding, what is it called? What's the word? Like piling on, because now it's showing how you can put if statements inside your for loops. You can put for loops inside your if statements, whatever you want to do, right? So just to combine what we learned about if statements with what we learned about for loops, this is saying same my numbers, same sum of big numbers, but this time I only want to add it to the sum. I only want to add it to sum of my big numbers if the number that we're looking at is greater than 2, right? So if we look at this closely, this code right here that's highlighted, this is the code that's going to run 6 times, right here. So this runs 6 times, but then notice that each time it runs, so it runs with 1 and 2 and 3 and 4 and 5 and 6. Each time it runs, the first thing it's going to do is hit this if statement, right? And it's going to say, all right, this number, that's the thing that holds the current list element. So this number, if it's bigger than 2, then it knows to do this further indented thing, right? It's like double indented this line because it's inside a if statement inside a for loop. But if you think about it, the for loop, when it starts, the first thing this number is going to equal is the first value of this number is going to be 1, right? So this number is going to be 1 on the first iteration, but it's going to say, all right, if this number is greater than 2. Well, it's not because it's 1, so it actually just doesn't do anything the first 2 iterations, right? So it says this number is 1, I hit the if statement, it's false, so I don't do anything. Then this number is 2, hit the if statement, it's still false, right? Because 2 is not greater than 2. So I don't do anything. It only starts running actual code, right? It only starts running the code inside the if statement from 3 onwards, right? Because then the third loop iteration, it'll say, okay, this number is equal to 3. 3 is greater than 2. So now I'll run this, right? And now I'll start adding this number to some of my big numbers. So in this case, we will get the sum of all the numbers in that list that are greater than 2. So that's 3 plus 4 is 7, plus 5 is 12, plus 6 is 18. So you get 18. Yeah. So the main thing to note there is that you know, just you can view the code inside of a for loop, just kind of, you can highlight it like I'm doing here, and you can like think to yourself like, okay, whatever this highlighted code right here, it's going to run 6 times, right? And each time it runs, this number is going to be set to the current element of the list that it's looping over. All right, and so again, you can put print statements and stuff, right? If this is just kind of another example, you can put print statements and then it's summing, and you'll see that you can see how many times the for loop runs because it prints for loop is still going 1, 2, 3, 4, 5, 6 times, which corresponds to the 6 elements of my numbers. And then for loop is done, right? This line is not tabbed, so after the for loop is over, it'll go to the next untabbed line, right? Cool. And yeah, this is kind of just a recap that you can, lists don't have to all be the same element type, right? The same variable type. You can have this, my new list, it has, first element is a string, but the second element is a int. The third element is another int, the fourth element is another int, and the fifth element is a string that says goodbye, right? And we've seen here that in Python, it doesn't matter whether you use single quotes like that or double quotes like that for strings. Other languages, it actually does matter, like in case you're worrying about that. Like in Java, you can only use double quotes for strings. In Java, you have to use these quotes because in Java, a single quote means it's a character, not a string, which is a different data type. But in Python, you don't have to worry about it. Cool. And so what this does is it says, okay, I want you to go through my new list, right? Pull out each element one by one and set each element, set rando to be each element, right? So in this case, the first time it runs, rando will be the string hello. The second time it runs, rando will be the number 5. Third time it runs, rando will be 3. Fourth time it runs, rando will be 2. And then the fifth time it runs, rando will be goodbye, right? And since all we're doing inside the for loop is printing it, we can run it and we see, yeah, it just prints it. And then it says, all right, I've hit the end of the code inside the for loop. So I'm going to loop back to the top and assign the next value in the list to rando, right? So hello, 532, goodbye. Cool. This is like a little bit weird. This might be a little unintuitive, but a string, if you try to like loop through a string, Python will interpret that as saying like, okay, I guess they're trying to loop through each letter in the string, right? So if you say this str in my string, it goes, okay, my str, it's not a list, right? If it was a list, that would be what we've done before, where it says, all right, I'll go through the list and I'll set this left side variable equal to each element of the list. But in this case, it goes, okay, well, now they want me to loop through a string. So its best guess is that you want to loop through the characters in the string, right? You can think of a string as a list of characters. So what it does is it says, all right, I will go through my string, the full string, and I'll set each character in order, put it in this string, right? So now if you print this string, it just prints each character in the string one by one, right? So the first time the for loop runs, it says, all right, I'll go into my string, take out the first thing, which is an H, capital H, and I'll put it in this string, right? And then your code just says print it, so you print an H. Then it says, all right, what's the second thing? It's a lowercase e, so this str will be a lowercase e, you print it, right? It's just going through one by one, but this is just to show you that, like, you know, the for loop, you can just like throw a ton of different types of variables in it, and it will try to be smart as to what you mean when you say loop over it, right? So it doesn't have to just be pure Python lists. It can be strings, it can be NumPy arrays, it can be pandas, data frames, you know, most things that can be thought of as collections of elements. In this case, a string, it thinks of it as a collection of individual characters. So that's how it interprets what you mean when you say you want to loop through my str. And so, yeah, this is honestly like the #1 most important thing that you'll learn. So sorry that it's taken so long to get here, because range is like the main thing that you'll be using in these for loops. range is just like a Python, built-in Python function that essentially is just saying, give me a range of numbers from this number to this other number in intervals of some third number, right? So if you just give one argument like this, range 10, that literally just says, okay, well, they didn't give a beginning of the range, so I'm going to guess 0. That's what Python, if you don't give it a beginning of the range, it just guesses 0. And I'm going to go up to 10, and you also didn't give an interval, right? So it's going to guess that the interval is 1. So that's going to start at 0, and it's going to go up by 1 a bunch of times until it gets to 10, right? But when it gets to 10, it's going to stop, right? Because remember, Python has this weird thing where the end of the range is exclusive. So even though this says range 10, it'll actually do 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It'll hit 10, but it'll stop, and 10 won't be a part of that range, right? So yeah, and then you can use it in conjunction with a for loop, right? So again, we have the for blank in blank. The second thing is what it loops over. So in this case, it is looping over range 10, right? So it goes through range 10, which is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And it says, all right, take each one of those in turn, set x equal to it, right? So the first time it runs, x is equal to 0. And then your code is just print x, so it prints 0. So then it goes, okay, next I'm going to loop back to the top. The next thing in range 10 is 1. So I'm going to set x equal to 1, run your code, right? So on and so on. Print 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Because it goes back up and it says, all right, it's a range 10. And the last iteration, I set x equal to 9. And that's the end, right? Because range 10 is just 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Cool. You can also specify a starting point. Like I said, if you don't specify a starting point, it just guesses 0, 0 to the number you specify, in this case 10, exclusive. But in this case, we can explicitly say, no, start at 2, right? So if we give range 2 numbers, it'll say, start here, go to here, exclusive. So this will print 2 to 9, because it'll hit 10 and it'll say, all right, range is exclusive, so I'm not going to run actually the end of the range. So it says, okay, cool. Range 2 to 10, go through each one, set x equal to it in order. So the first iteration, it says x is the first thing in this range, which is 2, right? And then it runs your code, it just prints 2. And then it loops back to the top. It says, all right, next thing is 3. So it sets x equal to 3 and prints, right? And so on and so on, similar stuff. Cool. And then, yeah, this is the third argument to range that I mentioned, which is you can say the interval that you want it to jump by each time, right? So before, you didn't give it an interval, and so it used the default interval of 1, right? It increased by 1 each time. Like in this case, it started at 2, and then it increased by 1, and it went to 3 in the next iteration. It increased by 1 and went to 4 in the next iteration. But you can have it jump, right? So in this case, we can set the iteration to 2, in which case, basically, it will start from this, and it'll go to this, but each time it'll jump 2, right? So in this case, it goes, okay, I'm looping over this thing on the right, and each element of it I'm setting equal to x, right? So it says start at 3. So the first round of the for loop, I'm going to set x equal to 3, and then run your code. Your code just says print it, so it prints it, and it says, all right, I'm done. Now it goes back up, but now it says, oh, there's a third argument to range, right, which is the interval. And it sees 2, so it says, okay, last time it was 3, then it wants me to jump 2, so now I will jump 2 up past 3. So the next iteration will set x equal to 5, right, and then 7, and then 9, and then it'll jump 2 again, and it'll hit 11, but it'll say, oh, the range was only from 3 to 10 exclusive, right, so 11, not in it, I'm done. Cool. This is a bit of a weird thing, which is that like Python for efficiency reasons, essentially is the best way I can explain it. When you say range, it doesn't actually make a list. Like I've been talking about it as if it makes a list, like, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That should be a 0. So that's what you would think, right? If I told you like, oh, hey, what's the range between, 0 and 10 exclusive, you would think, okay, it's a list of numbers, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. For efficiency reasons, because sometimes you'll be running a loop with like a million billion things in it. Python doesn't make that list because it's like, I don't actually need to make the whole list. I just need to like keep track of where I am, right? Meaning like, I don't actually need to make a list of a million numbers. I just need to know like the current number is 1. They want me to end at 10 and they want me to jump by 2 or whatever, right? So if you think about it from like an efficiency standpoint, it just only has to remember 3 numbers. Whereas if it made the full list, then your memory of your computer, like if you did range 1 billion, the memory in your computer would have to hold 1 billion numbers at a time, which is much less efficient than just keeping track. Like, I'm on this number, I'm going to jump by this many, and I'm going to end at this number, right? So basically, if you just print range, it doesn't print a list from 0 to 9 in this case. It just prints the word range 0 to 10 because, again, it's being smart with memory, and it's just saying, these are the instructions you gave me. Like, range 10 is just like instructions, right? To start at 0, increment by 1 until you get to 10 exclusive. So if you actually want to make, like, a lot of times they'll just like actually want a list from 0 to 9. Then you have to actually like explicitly convert it to a list, right? Remember, we have these Python built-in functions like, str and int. Well, we also have lists, right? Which will convert any number or anything you put into a list. So in this case, range 10, it's not a list as is, right? This highlighted object right here, it's not a list. It's actually like a range. That's a different type in Python, but we're converting it to a list, in which case it'll go, all right, fine, I'll actually make a list out of this range. Right, so now you actually see 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? But just keep in mind that Python is actually doing something different when you type range than making a list, right? If you use range, Python will only ever actually explicitly make the list with each individual element in it if you explicitly use the list function to convert it. Cool. And basically, you don't have to just, like, the for loop doesn't have to be like for x in range, blah, 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 blah. You don't actually have to always put the range here. You might want to just like keep a range, like say, you think, okay, well, I think I want it to run I think I want it to run from 0 to 10 inclusive, 0 to 11 exclusive, but I might want to change that later. You can actually make the range, set the range to a variable, in this case, my range, right? And so in this case, it'll say, okay, for z in my range, it'll go look at what my range is. It's range 0 to 11 exclusive, and it'll print it, right? But the nice thing here is that basically you say, oh, actually, I wanted, like, here, let's say you had a bunch. This will make more sense for x in my range. Print x for y in my range. Print y squared. For z in my range, print z, whoops, cubed. So say this is saying like, all right, I wanted to run one loop that goes through my range and just prints the numbers, but I want another loop that goes through and prints the squares of the numbers, and I want a third loop that goes through and prints the cubes of the numbers, right? And so we've got that, right? This one prints just the numbers. This one prints the squares, and then here's the printing of the cubes. But you go, oh, crap, wait, I want to actually like, I want to run it for more than 11, more than 0 to 11, right? Maybe I want to run it from 0 to 16 exclusive. Now you only have to change this one time, and then all the loops will change, right? Now it'll print the numbers up to 16 exclusive. It'll print the squares up to 16 exclusive, right? And it'll print the cubes up to 16 exclusive, right? So that's just like helpful because think about it. If I didn't do that, I'd have to update all 3 loops, right? I'd have to update this range, 16, range 16, range 16, And then if I said, oh, wait, actually, I want to go back to 11, right? You'd have to change them all again. 11, 11, 11, which seems, not that much work because it's only 3, but imagine if you had a program with like 100 loops. It'd be very helpful to say, okay, like loop range equals range, 20. And then you don't need each for loop, you can just use for x in loop range, right? So that's just to say that the ranges can be variables themselves, right? The thing that's after the in the for loop. And now we have the numbers and the squares and the cubes up to 20 exclusive. So yeah, this is saying the same thing. You can change the range. In this case, if we wanted to do like print like 90 numbers, you can change that. Yeah. So yeah. Oh, this is an important thing, which is that like the for loop, right? It's just runs and runs and runs and runs. And like I said, each time after it hits the end, it throws away the last value and it updates it to be the current value, right? So my var, it starts at 0 and then it runs your code and then it throws away the 0 and then my var is equal to 1 and then it runs your code and it throws away the 1, right? But if you think about it, like at the very, very end, when it's hit the end of the whole loop, it doesn't take the time to like throw away the last value. So actually after you run a for loop, you can use this myvar variable and it'll just be whatever the last thing that it looped through was, right? So in this case, let me make it a little easier. My list equals 1, 2, 3. Let's say for x in my list, print x, right? So what that does, right, it's what you've expected. It goes x is 1 and then print it, x is 2, print it, x is 3, and then print it. But now basically what you can notice is that we actually can use this x variable even though we're outside of the loop, and it's 3 because that's the last thing that it went through, right? So 1, 2, 3, if I say 1, 2, 3, goodbye, then it'll print 1, 2, 3, goodbye, and now x will be goodbye, right? So when you're done with a for loop, it's like kind of weird. I wouldn't really do this because it's very confusing to people when they're looking at it, but technically, yeah, you can use a for loop. It loops over everything, and then whatever your left-hand side variable was, right, your looping variable that changes each iteration, when you're done with the for loop, the value of that would be the last thing that it looped through. So in this case, goodbye. Cool. Now we get to the stuff I actually think is interesting, which is like stat stuff, right? So law of large numbers, there were some questions about it in Andrea's lecture yesterday. So I'm just going to go through it basically. Yeah, the law of large numbers, this is, by the way, this notebook is made by the head TA, Will. So thanks to Will for like putting it in such a nice, simple way, which is that law of large numbers is just saying if we take a sample of data, the mean of that sample will converge, however quickly or slowly, but it will converge to the mean of the population, right? That is the law of large numbers. If you think about it, it's actually like a kind of philosophical point or a philosophical law, because we don't actually ever get to like run things to infinity, right? We can only see finite things. So in the world, we only ever see like finite samples, but the law of large numbers is kind of this like mental assumption, like, oh, as I sample more and more and more people, I'm getting closer to like the mean of the people that I sampled. It's getting closer and closer and closer to the true mean of all people, right? So yeah, you can read through this. It basically just says like, as we take a bigger sample, the closer to whatever the true mean is. And just to be like very clear, this is, I think this is called like the frequentist assumption of statistics, which is the only type of statistics you'll learn in like an intro class, but I just want to be transparent. There's like a whole other philosophical interpretation of statistics called Bayesian statistics that you might have heard of, that kind of interprets the law of large numbers in a different way. And you can, Google Wikipedia that, but in this case, we'll say, okay, there's some like true mean out there, right? Like the true mean of dice is 3.5, right? It's like the expected value of the dice, or let me put it the true, if you have a fair coin, the true head proportion is 0.5, right? With 50% chance you'll get heads and 50% tails, like in your head in theory, even though in practice, if you sat there and flipped a coin, right? For like, if you flipped a coin 1,000,000 times, it would only like converge, like Andrea went over this in lecture, it would only converge to 50-50, right? You don't ever actually see the true thing because you can't flip a coin infinity times. You can only flip it a finite number of times. So law of large numbers is just kind of like the philosophical assumption that bridges that gap from we can only see finite things, but we say like, oh, the reason we say that a coin is fair, 50-50, that probability of heads is 50% is because we say, oh, that's the true thing, that we think if we flipped the coin infinity times, it would converge to 50-50, right? That's what the law of large numbers is saying. So yeah, say we wanted to know the average height of people in the US, right? This is like basic, like how surveys are done, right? Which we'll work with a lot of survey data. We've already worked with some survey data, but we'll work with even more survey data. And you might be working with survey data for your projects, but basically, right, like the whole point of a survey is you don't ask everyone. If you asked everyone, that would be called a census, not a survey, right? But so say we wanted to know the average height of people in the US. Well, one way we could do that is we could like drive around to find every single human being in the US and ask them their height and average it, right? That would be a census. But for most like purposes, we don't have the resources to go and ask every single person in the US their height. So instead, what we want to do, right, is we want to take like a sample of people and we want to be like, okay, well, how many, do I have to take before my sample hits before the mean of my sample, right? The average height of the people I sampled is like, when does that give me the actual average of the population, right? Law of large numbers is kind of the philosophical assumption that eventually it will, right? As you ask more and more and more and more people, basically the average of the people, the average height of the people you ask will get closer and closer and closer and closer to the true average. That's what law of large numbers is saying. So, if we sampled 5 people, the average of those 5 people, it's hard to say that that would be representative of like the average of all people in the US, right? Actually, it's kind of like a sad but true point that like you can get these data sets of like height in the world, and it turns out that basically like heights vary an absurd amount based on the average level of like nutrition or malnutrition in a country, right? So the tallest, like I actually looked at this, and like people in the Netherlands, right, which is like an absurdly like developed country with very few malnourished people, their average height for males is like 6 feet, whereas in some countries in Central America, right, El Salvador, Guatemala, Nicaragua, and Panama, like the height is like, the average height of males is like 5'4" and under, right? There's just things like, I think I mentioned to y'all that I spend every summer in like in the occupied territories in Palestine, so either the West Bank or Gaza Strip, and people in the West Bank are already like on average like much shorter than people in Israel, whereas people in the Gaza Strip are even much shorter than people in the West Bank, who are shorter than the people in Israel on average, right? So height actually kind of tracks like availability of food and resources and development of a place. So if you think about it, if we just sample like 5 people, that's probably more representative of like if I go outside here and I asked 5 people, I'm kind of just getting a sample of like this neighborhood in Tennessee, right? So the law of large numbers is kind of starting to say like, when can we start to think that our sample is representative, right? And the answer is like, as we sample more and more people from more and more places, right? So, we sample 5 people and we might randomly get like 5 basketball players. Like there might be a basketball game outside and those are the 5 I happen to sample, and they're all like 7 feet tall. Can we say the average height of people is 7 feet? No, you have to sample more and more people from more and more places. So if we sample 50,000 people, right, that would be a lot closer to the average. If we sample 500,000 people, then we get even closer. If we sample 5 million people, we get even closer, right? Like that's the intuition of the law of large numbers. It's just sample more people, sample people from a wider range of, you know, places and backgrounds and locations and stuff, and your sample will become more and more representative of the actual average of the population. Yeah, it's the, to like tie the thread, the point I was saying about different countries and territories having different heights is just that, like, you know, if you're in Panama and you're taking samples of heights, you'll get a much smaller number than if you're sampling in the Netherlands, right? So it's not only the number of people that you sample, but also like the breadth, like where you sample them from, right? Are you sampling people in prison? Are you sampling homeless people? Are you sampling people who live on ships? You know, like how representative is your sample, both in number and in the number of people, or the range of people that you're asking. I just want to point out that there's kind of two axes of variation there, right? There's just the pure sample size. As that goes up, it will get more and more representative, but then also there's like the range of people that you're asking. And as you ask more and more different people, the more accurate your sample will be of the population. Cool. So what we're gonna do here is we're gonna basically just like show what the law of large numbers looks like in code. So basically what we can do, right, the nice thing about simulations, the reason we use them is because we can create the truth, right? Like we can artificially create a population of people and like assign them heights. And then if we can figure out, you know, their truth with our statistical methods, right, with our sampling methods, it's evidence that our methods work, right? So law of large numbers, we can like kind of put it to the test, right? We can say, all right, I'm going to create a population of like 1 million people, and I'm going to set their like heights specifically to be like average, you know, say 5'5". I should use centimeters for the international audience. Sorry. So I can set the population to like mean 168 centimeters, right? And then I can just like take bigger and bigger in samples and see, oh, does it actually, like as I take bigger and bigger in samples, does the mean height of the sample I'm taking actually converge to 168 centimeters, which I know is the height of the true population because I made it, right? So that's why we do these simulations. It's just kind of like to test out that our intuitions, you know, that law of large numbers, and as we go further in the class, the statistical tests actually work. So great. This is created by Will. So we have a new country called Willopia. It's the best country, it turns out. It has 10,000 people, right? So the full population of the country is 10,000. So what we're going to do is we're going to create like the truth, because what we can do is we can actually create 10,000 people, right? We can create the full population of the island artificially using code, and then find the actual mean height of the full population. And so, yeah, you don't need to follow this code, but it's this, all this does is it creates normally distributed random variables. We learned about the normal distribution, right? But we're given the mean height of 168 centimeters, but the standard deviation here is 5. So basically, you know, when you see surveys and stuff, this is saying the actual population height is 168 plus or minus 5 centimeters, right? So it's like, yeah, hopefully you get it, but like it's a bell curve where the center of the bell curve is at 168 centimeters, and then one standard deviation above that is 173 centimeters. One standard deviation shorter than the average is 163 centimeters, right? And we say size, well, it should be 10,000. So let me make this 10,000. So yeah, what this does is it creates 10,000 random normally distributed variables with mean 168 and standard deviation 5. So now let's graph that like actual data. So we take the actual population heights, right? That's what we made here. It's a list of 10,000 people's heights. And we plot it, right? And it's basically a normal distribution centered around a mean of 168, right? So the x-axis here is height in centimeters, and the y-axis is how many people have that height, right? So 168 is like right there, and like the mode, right? Like about 1,000 people have a height of 168 centimeters. Then there's variation, right? Because it's a normal distribution. So like almost 1,000 people are a little bit shorter. They have 165 centimeters. And then almost 1,000 people are a little bit taller. They're like 170 centimeters, right? But as you like, there are very few people, there are some, but there are very few people who are like 185 centimeters. And there are very few people who, but there's some who are 150 centimeters, right? So it's just our standard normal distribution. And then remember, this is like the population. So this is saying we know mean of the population here is, well, let's just compute it, right? So we have our population heights. Let's just take the mean. Population heights. All right, so the actual like true mean of the population that we created is 167.98975, right? So we created a synthetic population that has mean height of 167.98975. And now, right, hopefully you follow what we're doing. We're gonna use this law of large numbers thing. We're gonna start taking samples from this population, right? So we're not gonna be able to look at all 10,000 people. We're gonna pretend like we walk onto the island and we ask like, 5 people. So here, what we're gonna use is this function from NumPy called np.random.choice, right? That randomly chooses a person, like an element of the list. So in this case, it randomly chooses a person from the population heights. So great, we sampled from the population heights. We got someone with a height of 165.928 centimeters, right? So a little bit like below average height. But we could run it again and look, I got someone who is 173 centimeters, so pretty above the average height, right? And we can just run this as many times as we want, pulling random people from the population. So let's do it in a for loop, right? We see the beauty of for loops, which is that we can run a loop 5 times to get 5 samples, right? So we say sample size equals 5. We have this list here, right? We started as an empty list, all samples. So it starts out empty, but we're gonna fill it in the for loop, right? And we say, go through range sample size, meaning 0, 1, 2, 3, 4, because sample size is 5. And for each one of those, set it to this iteration, right? So each time through, we say this sample, right? So each of the 5 iterations, we run np.random.choice, chooses a random element from population heights, and sets it equal to this sample. And then all samples is the list we made above, append, right? We add this sample to it. Cool. So the loop runs 5 times, and each time the loop runs, we take a random choice from the population heights, add it to all samples, right? So by the end, we have this sample, right? Went through the population, sampled 5 people, and saved them. So there's someone with height 159 centimeters, someone that's below the average, but then someone with 169 centimeters that's above, 71 that's above again, 163 that's below, and 165 below. So if we sample 5 people, those are the heights we get. Now, what's their mean? Get 165, which, does it make sense? Yeah, because we have this person, and this person are all below the mean, whereas only 2 people, right? This person and this person are above the mean. So out of 5 people, if 3 of them are below the mean and 2 are above, the average should be below the mean. And indeed, yeah, 165 is below the mean. And it's not far from 168, right? So now it's like, the average of our sample is 2.163 centimeters from the actual population mean, right? So you sample 5 people, you're like a few centimeters off. But what if we sampled 1,000 people, right? So this is the exact same code, but with sample size changed to 1,000. So now we just sampled 1,000 people, right? If you want, you could like print out what it looks like. All samples new. You get like 1,000 heights, right? So we went around the island Willopia and we sampled 1,000 people and we measured their heights, right? And this is our data set right here. Cool. And so what happens if we take the mean of that bigger sample, right? What we learned about the law of large numbers is that if we take a much bigger sample, right? Before we took 5 and we were 2 centimeters off. If we take a sample of 1,000 people, we should be way less than 2 centimeters off, right? So now let's take the mean of our new sample of 1,000 people. We get 167.89. that's pretty close to 168, right? That's 0.1 centimeters off from the actual mean, right? So check it out. What if we do, so there's only 10,000 people on the whole island, right? What if we did 5,000? So at this point, we're sampling like half the people on the island, which is a lot. Like if you went through and sampled half the people in the US, that would be 170 million people. And already that's like cost prohibitive. But on this island, let's say we can go and ask literally half the people for their height. Now we take the mean and actually it's kind of worse. That's weird. So now it's 0.124 centimeters below the actual average. What if we ask 9,000 people? So now we're asking all but 1,000 people on the island for their heights, yet now we're 0.07 centimeters off. So if we ask, 9,900, so now we're asking every single person on the island except for 100 people, right? That means, now it's 0.15 off. What if we ask all but one person on the island, right? Yeah, we're still getting 0.07 off. So basically, yeah, the idea is like I went too high too fast. So, if we started with 10 people, we'd be 2.2 centimeters off. Then if we went to 100 people, it'd be only 0.02 centimeters off. And if I went to 1,000 people, it'd be 0.07. So the point is kind of just that you get better and better approximations of the full population as you sample more and more of the population. Kind of didn't work because I'm going, also I think this is random.choice without replacement, with replacement, whereas we'd really want to sample without replacement, right? But yeah, just to like drive the point home, I'm making a new country called Jeff-topia, where instead of 10,000 people in it, there's 1 million people in it, right? So that's 1, 2, 3, 4, 5, 6. So I'm making 1 million people, right? Each with average height 168 centimeters with a standard deviation of 5. The average there is 167.996, so almost exactly 168, right? And we can plot those. Whoops, we get like a fully normal distribution again. All right. And now if we can do what we did before, randomly sample people. Now, this example will work a little better because I'll scroll down here to the end and I'll say, all right, what if I sample 10 people? Remember, my island now has 1 million people on it. I sample 10 people, I'm 0.566 centimeters off. I sample 100 people, I'm 0.27 centimeters off. So I've cut my error in half, right? I sample 1,000 people, I'm 0.19 off. I sample 10,000 people, I'm 0.12, right? So this is what I was trying to get at, is that as you sample more and more people, like orders of magnitude more people, the average of your sample gets closer and closer and closer and closer to the true population average. That's all the law of large numbers is saying, and we just like put it into action here by making a fake population where we know the actual average of the whole population, and then we just sampled small portions of that population, and we saw that as that portion of the population gets bigger and bigger and bigger, the average of that sample we take gets closer to the average of the population. So cool. Hopefully you get that. Yeah, and like I said at the beginning, office hours are by appointment. I'm about to go check my emails because I know there's a huge backlog of people who have asked to, meet with me over Zoom and stuff. So I'm going to go through that and I'm going to reply. So if you've already emailed me, I'm getting to it ASAP. If you haven't emailed me, feel free to email me about any of this stuff, right? Because it'll be on might be on the next homework or on the next lab. So make sure you get the law of large number stuff and the for loop stuff. And yeah, thanks.